Good evening once again and welcome to Naija Pikin. Do not forget to like and hit the subscribe button. We're going to continue from our last video. We were talking about the adaptive immunity and how the adaptive immunity mounts its response against a viral infection. So I stopped at where the CD8 pre-cytotoxic T cell was activated. Cytotoxic T cell was activated to a CD8 cytotoxic T cell. So if you want to understand how we got here, you have to visit our last video to get the bigger picture. Okay, so the CD8 now, for it to do the killing, it produces IL-2, not IL-12 from the previous video, IL-2 as a cytokine, which is self-stimulatory, meaning it will allow the CD8 cell to undergo clonal expansion or self-expansion and make plenty copies of the CD8. On the body of the CD8, we have the Fas ligand. So I'm just going to write it this way. Then the CD8 will look for an infected cell. To look for an infected cell, excuse me, it will look for an infected cell. And do not forget, I told you, do not forget that we have a Th1 helper cell here that produces IL-12 and interferon gamma. I told you from the last video that I was going to tell you the function of interferon gamma. Now you're going to see the function of interferon gamma and how it helps in the killing. What it does, what does it activate? Interferon gamma that was produced from the Th1 T cell. Okay, this is an infected cell, and do not forget I told you every nucleated cell have MHC1, but when it's infected, there is no expression of MHC1 on the body of an infected cell. So this is what happens on the body of the infected cell. We have Fas on it. We have Fas. We have Fas on it. So when these two things are bound, do not forget I told you on the infected cell, MHC1 is not expressed. What is the function of this interferon gamma? Interferon gamma goes to the infected cell and tells it, please start producing MHC1, start expressing MHC1 on the body of your cell membrane. So MHC1 is now expressed. What happens? Do not forget, the viral peptide is here. The viral peptide is here. So this now binds your T cell receptor, mediated by CD8, of course. Mediated by CD8, of course. This now stimulates the CD8 to produce two particular enzymes that will now do the killing. The same thing, perforins and granzymes. You see? Just like the NK cells in the innate immune response. And do not forget, CD8 cells, CD8 T cells are modified. CD8 T cells, CD8 T cells and NK cells. NK cells are modified CD8 T cells, modified CD8 T cells. So because they both produce perforin and granzyme to do the killing. This is the killing for adaptive immunity. This is the last bus stop. This is the last stop for adaptive immunity. This is where it all ends. The CD8 cell, since it's now activated, it produces IL-2, which is a self-stimulatory substance that allows clonal expansion. And on the body of the CD8, you have the Fas ligand, which will now find an infected cell, bind to the Fas on the infected cell. The infected cell have MHC1 on its body, but it does not, the infected cell does not express it. But the interferon gamma produced from the T helper cell that allowed the activation of the macrophage also produces this substance to allow the infected cell to express MHC1 on its surface, which now attracts the attention of the CD8 cell. It binds way to the T cell receptor mediated by the CD8. Boom. CD8 produces perforin and ganglion that does the killing, or cell what? Apoptosis. Thank you. Cell apoptosis. Beautiful. But what is most interesting about this whole thing is this. From the first time I started teaching this topic, I told you I'm going to give you 3 illustrations of the bandits, the police station, and the barracks where the soldiers are situated. Now we're done. We've killed. Now we were able. The infected cell, we were able to take care of it. The bandits came in, took time and destroyed and killed the whole policemen in the police station. But when they actually came to the barrack, we were able to take care of this thing. This is all this. But after taking care of this stuff, after taking care of this little banditry that we have, how do we now save machineries? How do we now devise a strategy should, in case we have this type of invading bandits? What do? We need to have a bank that will save our machineries. We need to have an arsenal that whenever we do come, we know this is the type of gun, this is the type of ammunition we need to attack this set of bandits. So we don't need to follow the same processes. We can even teach the police station. They don't need to come for our help anymore. They can just take care of the problem and we don't have to be called one way or another. So I'm going to use this same illustration and bring you back to the picture and you can now connect. So since the infected cell is killed by the adaptive immunity, now what do we do in case we have this same virus in our system? What do we do when this same virus infects the cell? What do? We need a memory. This is the reason why immunology is so beautiful. It will definitely save a memory in case of an emergent or an existing virus. The type of the virus, when it comes into the body again, if it comes again, it's reoccurring. It will understand that yes, I have fought this type of virus, this is what I'm supposed to do. So I don't have to go through 2 weeks before my innate immune system will be done and I have to know. I have memory banks for this. So this is what happens after the infected cell is being killed. The body, the immune system will be able to produce and have a memory bank for the fight against viral infection. So this will be the last. I hope you understand this. Please, I want you to go into it. See things for yourself. Understand it. It's very beautiful and it's self-explanatory. Just follow the keywords that I used and you'll be there. You'll enjoy it. So now, we need a memory. When we need a memory in the body, what do? We go for the B cells. B cells. So we go for the B cells. So now, okay. Stop that video. Stop the video. Now